All right, everybody, welcome here to the video for lesson number 8 on compounding interest. So essentially, we learned in class today that there are kind of two formulas that we can use to represent interest. We can say F equals the principal times 1 plus the rate all to the amount of years T. Or if we have something here that is compounded more than once a year, we can say the future value is the initial principal value, 1 plus the rate divided by the number of compounds, all to the number of compounds times the number of years. And we'll actually see within this homework assignment, we'll start to look at how we can have a yearly or annual rate and how that can be both what we call nominal and effective. But we'll talk more about that later. So let's start easy. So it says April has $200 to invest in a bank. Walden Savings Bank has an annual interest rate of 6.5% compounded annually. So we'll use that first formula for Walden. It then says KeyBank is offering her an annual interest rate of 5%, but it's compounded monthly. All right, that would be 5% would be what we call the nominal interest rate. Right, so it's an annual interest rate that's just compounded throughout the year. Right, so then she says, assume that we do not make any more withdrawals or deposits. So this is just the only money that we're putting into this account. So if we create a function for W, so we could say W of T is equal to her initial amount of $200. That's her principal. 1 plus the rate. So for Walden Savings Bank, it was 6.5%, so 0.65, all to the T for the amount of years. Now, I want to clean that up a little bit. I don't like to have the parenthesis have a sum in it. So if I can add or subtract something, I want to do that. So we have our number here for the W of T function. For the key bank function, so K of T, I'm going to have also $200 as my principal. 1 plus, now this rate's different, it's lower rate, so 0.05%, and it says compounded monthly, so that's 12 times a year, all to the 12t. Again, we want to kind of try and simplify that a little bit, so let me go to my calculator here, because I don't know how to do that in my head. So we have 1 plus 0.05 divided by 12. Again, Desmos is a great tool for this. So we can kind of get our answer here. These are going to be messy decimals, right? So we just want to round out. We said in class 4 decimal places, so 0.0042. So we can go back here. So we could say the KeyBank function is going to be 200 times 1.0042 all to the 12t. All right, so then it says April plans to leave her money in the bank for 4 years. Which bank account should she invest her money in? So we want to evaluate what is W of 4. So we have 200 times 1.065 to the 4th power. And we want to evaluate K of 4. And I'm actually going to use the original non-simplified one because we rounded here, right? You really probably could use either one. It probably won't make a difference. You're probably talking about changing like the 6th or 7th decimal place. It's not going to make a difference when we're talking about money, but we'll just use it anyway. So we'll put a 4 in there in the exponent for the number of years. So then we just have to make a couple quick calculations here. So if we type these both into our calculator, we can find our values. I'm just going to pause here for a second so I can do that, not waste your time. All right, so as you can see, I evaluated both. So for the Walden Savings Bank, we have $257.29. And for the KeyBank Bank, we have $244.18. Again, just rounding to the nearest cent here whenever we're talking about money. So what we could say here is the Walden Bank account is going to be better, right? Because it will generate more money, right? So we always want to try and get the most money unless the context of the problem says something different. All right, let's talk about number 2. So number 2 says a bank has a nominal interest rate of 1.5% and compounds its interest at the end of each 6-month period. So that's going to be twice a year. And again, this word nominal is just kind of like the fancy word for the annual rate, right? So we're saying that we're taking this rate over the course of the entire year, right? We're just going to compound it different times. So since it's compounding twice, it's going to be, 0.75% twice a year. It then says if the initial amount of $1,000 was invested, how much money would be in the account after 3.5 years? So we can say the future value is equal to the initial value of 1,000 times 1 plus 0.015 over 2, all to the 2 times 3.5. And again, we're just typing that into our calculator here. So we have 1,000 parentheses 1 plus it was 0.05, I think. No, 0.015, that would be better. Divided by 2. Nice thing about Desmos is it does everything for you. It is a good feature. And then we have 3.5 times 2. So $1,053.70. So the future value here is $1,053. What was it? I don't even know. $53.70. Not too bad, right? The big concept here is really just, do you know these formulas and how to use them? That's it, right? Unfortunately, they're not given to you on the Regents, so I'm not going to give them to you in class. All right. Next one says an investment of $500 made 2.8% annual interest rate compounded monthly. All right, find the amount of money after 6.25 years. So we could say the future amount, $500, 1 plus 0.028 over 12, since it's 12 months, all to the 12 times 6.25. And then it just honestly becomes, can you type that into the calculator correctly? All right. Again, I'll pause the video here for a second so that I can type this in, not waste your time. All right, so if you plugged it into your calculator correctly, we have $595.50. Now let's talk about something new. So the next part of the homework assignment is actually something we did not do in class. I'm hoping that you can kind of figure this out on your own or with my help here through the video. So it says, while the nominal annual percent rate is 2.8%, properties of exponents can be used to reveal the actual, or what we call the effective, annual percentage rate. So what this means, right? So when we have a nominal interest rate that's saying I'm taking this money and I'm going to take this 2.8%, and every single month I'm going to do 1/12 of that number. Well, to find the actual percentage rate for the year, it's not going to be 2.8%. It's going to be a little bit different. Because if you think about it, if I'm doing a part of 2.8% every single month, then that means the next month I'm going to have a bigger value that I would not have had if I didn't have that annual percentage rate chopped up into 12 pieces. So if we take a look at this initial value here that we have, so if we take F, the 500 is not going to change, and I want to figure out, well, what does this piece come out to be if I type that into my calculator? So if I just take the part of the parenthesis here, and I type that, just that part into my calculator, I get 1.0023 repeating, right? So again, I'm just going to round that out 4 decimal places. So I have 1.0023, and that's all to the 12t. Now remember, and the key here is that t represents years. So right now, this value is still in terms of the nominal percentage rate of 2.8%. But if I rewrite it so that the exponent is not 12 times t, but the exponent is just t, what I've now done is made it so that whatever's in this parenthesis represents the annual interest rate, the real one, not the one that's been chopped up 12 times. So now if I take that decimal I had in my calculator and raise it to the 12th power, right? So if I take that number that's in my calculator and raise it to the 12th power, I get this decimal. Again, rounded out 4 decimal places. So I have 1.0284. And now if I want to figure out what my effective percentage rate is for the year, well, I could take this number, 1.0284, subtract 1 from it, and I get 0.0284. Well, that's the rate. That's the effective rate, not as a percentage. So if I change it to a percent, just move the decimal place twice, and I have 2.84%. Now, it looks like it's almost the same, but it's not. Notice it's a little bit more. The reason why it's a little bit more is it's taking into consideration that we're compounding the interest as well as just the initial value of $500. Now, sometimes when the interest rate is bigger, the effective interest rate will be much bigger than the annual nominal interest rate. So it's something just to consider when looking at it. So the difference here, again, is the effective interest rate is the interest rate where we take into consideration the interest is also compounding. All right, we'll talk more about this in the next lesson, all right, but I was hoping that you were able to get at least part of that in this lesson. Number 4 says a checking account has 2% fee if a checking account is not used during a year. An annual account of $10,000 is left inactive for 4 years. Change our future value model so that it represents decay. So we talked about this a little bit in class today. So instead of being a sum inside the parentheses, if we make it a subtraction sign, right, then we can make it so that it becomes decay. So my future value is going to still start with $10,000, but I'm going to subtract 0.02%. And this is going to be every year. All right, so every year they charge 2%. So our exponent here is 4 for inactive for 4 years. Now, if we clean this up a little bit, 1, to make it easier to type into my calculator, and 2, just so we could see, this is going to be a decay model because the base is less than 1. All right, it's one of those values that's between 0 and 1. So then we could go through and just type this in our calculator. All right, that's an easy one for me to do here real quick. So we have 10,000 times 0.98 to the 4th power. So I have $909,223.68. So we can see that this decay model is actually making that account go down a decent amount over the course of 4 years. Hopefully this video helps. We will keep going here as we move forward. All right, just keep in mind, all right, it's all the same stuff over and over and over again. We're just looking at all the different variations that we're doing here with these word problems. All right, so don't get frustrated. All right, good luck with your homework, and I will see you all tomorrow in class.